Want to run PolyBase against local data? Let me show you one way to do just that. Welcome to this quick hits video. My name is Kevin Feasel and I'm the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In a prior video, I showed how you can use MinIO to serve content using the S3 protocol. In that video, we used the service to store database backups. In this video, we are instead going to read data from MinIO and display it in SQL Server using PolyBase, SQL Server's technology for data virtualization. Let's skip the classroom this time around and get straight to the demo. I am in the Windows terminal, staring down at a PowerShell prompt. The reason for this is that I'm going to stand up a container running MinIO, a service that offers a compatibility layer following the AWS S3 API. The reason we want to use MinIO is because I'd like to take some data files that I have locally and query them using SQL Server. To do so, I can use the SQL Server PolyBase technology, which acts as a data virtualization layer in SQL Server. Specifically, as of SQL Server 2022, Microsoft introduced S3 compatibility in PolyBase, letting us query data in S3 buckets or S3 compatible storage. That ties us back to MinIO and thus to the prompt that we're all staring at right now. Some of the commands and instructions here will be very similar to my video on backing up SQL Server databases to S3 buckets, as many of the mechanisms will be the same, particularly around deploying and configuring MinIO. But don't fret. Regardless of whether you have seen that prior video, this is a standalone video, and although there will be some topic overlap, we will also cover new ground here. The first thing I want to do is ensure that I have the latest version of the MinIO container image. You do, of course, need to have Docker installed on your machine to do this. On this machine, I'm using Docker for Desktop on Windows, but the commands will be the same regardless of the specific tool that you're using. Next up, let's start a MinIO container. This is a PowerShell script, so I need to indicate line continuation via the backtick. If you're following along and are using Bash or the shell in macOS, you likely will need to replace the backticks with backslashes. What this command is doing is starting up a new container using ports 9000 and 9001. Port 9000 is the port that we will use for API access, and 9001 is the port that MinIO uses for its web interface. I'll call the container MinIO1 and set up a persistent volume running on my D drive in the MinIO/data directory. Locally within the container, we will reference this volume location as /data. I am also going to set the root user and password. If you're going to keep this container running for a while, you'll probably want your own password. This one is a pretty good one, but it's mine. I'll also note that there are going to be two network addresses for this container. The first is my local machine, 127.0.0.1. Because we are exposing ports 9000 and 9001 through the container, I can access via my PC's IP address. I'm going to stick with localhost here, though if you were going to host the container on a networked server, you would want to use that server's IP address rather than localhost. The second network address for the container is an internal Docker address. It's a 172.17 address. I'll need to know both of these addresses later, as I'll need to set up a working certificate in order for SQL Server to communicate with MinIO, and if I have any Docker containers that should communicate with MinIO, those will talk over the 172.17 address. Let's switch to my browser now and navigate to localhost and on port 9001. I'll need to log in, so I will enter root user as the username, following that up with my password. Doing so will put me in the object browser, where we can see that I have no buckets. Buckets, by the way, are S3's construct of logical containers, keeping data separate. MinIO represents buckets as folders on our file system. I'll create a bucket and name it PolyBase, as we're going to store some various data in there. After choosing the name, I'll select Create Bucket. Now that I have a bucket, I also want an access key for SQL Server to use. So I'll navigate to the Access Keys page and select Create Access Key. It auto-generates a reasonably strong access key and secret key. I'll set that name to PolyBase as well, and then I'll select Create. This gives me a screen with the access key and secret key in plain text, so let me copy and paste these into Notepad before I close this window. That way, I'll be able to use them once I get to SQL Server. Before I move on, there is one more thing that I need to do, and that is to load in some data. Navigating back to the object browser, I can see my PolyBase bucket. Selecting that, I get a message that the location is empty. Let's rectify that by uploading some files. Specifically, I will upload a file containing population estimates for the state of North Carolina. This will only take a moment, and it will make the CSV file available to me later. The next thing I'll need to do is create a self-signed certificate for MinIO and put it in my trusted certificates list on Windows. I am going to open up a new terminal window, this time using Windows Subsystem for Linux. I already have that installed and configured, and it will make generating the self-signed certificate so much easier. In a production environment, you wouldn't do this, of course. You would get an actual signed certificate and you would deploy that. Or maybe you'd actually upload to Amazon S3 rather than to local S3 compatible systems like I'm using. Inside of here, anyhow, I'll navigate to /mnt/d/temp, a directory I created a while back. Next up, we'll create a file called openssl.cnf. In this file, I define a pair of IP and DNS entries. We'll primarily use localhost, though if I had another container running, such as if I was using the containerized version of SQL Server on Linux, I would reference s3.localhost instead. Now that I have the OpenSSL configuration file, I can create a private key and a public certificate in the same directory. Great. A quick check with ls shows that I have two files starting with the letter P, private.key and public.cert. I now need to copy these two files to the MinIO container and restart it. I can do so with 3 commands. This is only going to take a moment given how small the files are, but now that I have this in place, MinIO will use this self-signed certificate covering one half of our transaction. The other half of the transaction is my SQL Server host, which is my Windows desktop. In order to add a trusted certificate to Windows, I'll open up the Start menu and type in Manage Computer Certificates. I can see an entry for Manage Computer Certificates, which I will select. That will lead to a UAC prompt. So as soon as I approve that UAC prompt, I'll get the certificates list and drag it over so that you can see it. Inside of the certificates list, I'll navigate into Trusted Root Certification Authorities and then Certificates. I can see all of the root certs. I'll right-click and from All Tasks, choose Import. From there, I'll select Next. This brings me to a file selection menu, so let me paste in the location of my public certificate. I'll place it in the Trusted Root Store and select Next. Finally, I can finish the job and let importation complete. And if I check the list, I do see a certificate for s3.localhost. Okay, that's done, so we have the means to do what we need to do. Before I move on, I have one more thing to note, and that is, I'm assuming you already have PolyBase installed and configured on your SQL Server instance. If you do not, I'm including a link to a talk that I deliver on data virtualization in SQL Server 2022. I have a couple of video deliveries of the talk, as well as slides, demos, and additional resources to help you get started with PolyBase. Now it's time to move on to Azure Data Studio. In Azure Data Studio, I'm going to start off by opening up a new query window in the database I would like to use. I have a database named Scratch, and it will be my target of choice. Before I get too far, here's a really quick primer on PolyBase. There are 4 things that we are going to need in order to communicate with MinIO: a database scoped credential, an external data source, an external file format, and an external table. I'll describe each one as I show you their creation scripts. The first thing we need is a database scoped credential. This is our way of showing that we are authorized to access these resources in S3. Before I can even do that, however, I need to open a master key. I happen to have a master key for this database already, and I'm using a secure key to encrypt that data. But if I didn't have the master key already, the first part of the query would run it and would create one for me. Now that I have a master key, I can create a database scoped credential. The reason for this is that SQL Server uses the master key to encrypt the database scoped credential. I'm naming my database scoped credential similarly to how I named the credential I used in the backup video. That said, the database scoped credential name does not need to follow this exact format. You can choose whatever you'd like for the name, as it won't make a difference for PolyBase. The identity specifies that this is an S3 access key, and the secret is the actual access key details. I need to paste in the access key and secret key, separated by a colon, in here. After running that script, it's time to create the next resource, and that is an external data source. An external data source is a pointer to where we are going to host the data. In my external data source, I only need to define 3 things. The first is the name of the external data source, which I'll make S3 PolyBase bucket. Next, I need a location, which is where SQL Server is going to expect the data to live. Because we are talking about data virtualization, we are not hosting the data in SQL Server itself. Instead, we query the remote data source whenever a user has a request for its data. The final thing I need is my database scoped credential. The next external object type I need is an external file format. Let me paste in this script and explain what it's doing. We are first checking to see if I already have an external file format named CSV file format with header. If so, we carry on. If not, we create this external file format. PolyBase supports a few different types of file formats, though the 2 most popular ones are delimited files and Parquet files. If you're a completionist and you want to know the other 2, it's ORC, optimized row columnar, and RC file, which hopefully nobody's been using since about 2012. For delimited text files, we need to specify a field terminator. For CSV, I'll specify a comma. Next, because this is a CSV file with a header, I'll specify that the PolyBase engine should look for the first record at row number 2. In other words, we're going to ignore the header altogether, as PolyBase doesn't support reading headers and inferring column data from files. After that, I have a few more attributes that will not be all that relevant in this case, though I do talk about them a bit more in that PolyBase talk that I referenced. Our last interesting PolyBase asset is the external table. This is how we define the shape of the data within our file. SQL Server demands an exacting specification of data formats, as we are dealing with structured data here, even if the underlying data file is much less structured than what SQL Server expects and demands. In this case, I am creating an external table named North Carolina Population. It has several column names, as well as data type specifications, data length specifications when necessary, and an indicator to determine whether the column is nullable. Below that, we have a with clause and some PolyBase specific information. I am specifying that my data source is my MinIO external data source, and that the location within the PolyBase S3 bucket is North Carolina population.csv. The file is a CSV file and it has a header. We also have this notion of reject type and reject value. Not all records may fit in the structure that we've defined for this external table. Let me create the table and I'll show you an example of what I mean by this. This is a query selecting all columns from the North Carolina population table. As I run it, I get 3 nasty looking error messages indicating that there was a bulk load data conversion error on 3 rows and the population column. These are examples of rejected rows, and if you dig into the file, you can actually find out that these rows have a population value of the letter A rather than a number. Scrolling back up just a little bit, I've defined population as an integer column, so of course a row with the letter A in the population column is going to fail. But what's nice about setting a rejection value greater than 0 is that I can just reject these rows and still return the rest of my results. I have 13,607 results, so instead of failing the data file because a couple of rows were bad, I can get back all of the good rows and troubleshoot what's happening with the bad rows. Great, now we've seen that we can retrieve data from local disk via PolyBase. Granted, we need to ingest it into MinIO first, so it's not as simple as reading CSV files or Parquet files from the file system directly. But this isn't the only thing that you can do. You can also save data from SQL Server into S3 compatible storage. In order to do that, I am going to make sure that I have PolyBase export on. This is a configuration setting that we used for PolyBase in SQL Server 2016 when writing to Hadoop or Azure Blob Storage. This may not absolutely be necessary, but it doesn't hurt to have it on. Next up, I'm going to create some really simple data in a temp table. Copying and pasting this into the new query window, I can execute the script, and now I have some data that I'd like to write to a file. Let me first show you the wrong way, just to see what kind of error we'll get. I'm going to create an external table called PolyBase test. This is very similar to the prior external table, and if I run this script, it works. Now let's try to insert some data. As soon as I try to run this query, I get an error telling me that DML operations are not supported with external tables. In other words, I cannot use insert, delete, update, merge, truncate, or any other data modification command. But there's a trick. I'm going to drop this external table and then I'll show you the trick. Now let's use CETAS syntax, and that's create external table as select. This statement generates an external table based on a select statement. We specify the data source as S3 Polybase bucket, and we're writing to a new file, polybasetest.csv. The contents of the table will be the result of my select operation, loading all data into the file. This ran and told me that it inserted 3 rows. So let's query the table now. Running this script, we can see that the rows are in fact there. Before I wrap this up, let me give you a warning. You cannot delete data from this table or otherwise modify the data once you've created your external table. If you needed to change any data in the file, you would need to download it from MinIO, make the modifications in some other file editor tool, and re-upload the data. This means that your data modification capabilities are very limited with PolyBase, but it is possible. And if you drop the external table, it does not actually delete the underlying files. So if you drop the external table and then create again an external table as a select statement, it will append that data to your existing files instead of replacing the data. So just keep that in mind. And that's going to do it for this quick hits video. We had a chance to see how we can use PolyBase and MinIO to read data stored on a local disk in SQL Server, as well as how to write data from SQL Server into S3 compatible storage. We'll have links and show notes in the description below, and until we see each other in the next video, take care.